Hello, Professor Fabio.
So I don't know if Anita is coming, but you have a bit issue with our session chair.
Yeah, I think he's
But
having
no
some technical
problem.
issues.
So hi everyone. Thank you for being here in this session. And I will help you to conduct. So as a backup in the session. So thank you so much to be here and in the release engineering and DevOps 2 session. So let me see what our papers, because I come here in now. So let me see. Okay, that's it. In fact, we have 5 papers. So who don't know me, my name is Fábio Petrillo. I'm from École Polytechnique. Oh, sorry. I'm so before I was in the École Polytechnique brand. Now I am École Supérieure de Technologie Supérieure in Montréal. So I'm here to help you conduct this session. So please, the first work that you have is an empirical study on release notes patterns of popular apps in the Google Play Store. Aidan, please, the floor is yours. Who is the presenter? Aidan? Could you please share your screen? And unmute your microphone. Okay.
Hi, sorry. Just give me 1 second to share screen.
Sure. Take your time. Take your time. Take your time. There is a button in the left corner. And okay, great.
Are you able to see the?
Put in presentation mode because it's in. Yeah, switch that.
Yeah, I'm not sure how to get just the presentation.
Display settings, the second bottom.
Yeah.
Display settings.
Yes.
Yeah.
Is that good?
Yeah, perfect.
Okay.
Perfect.
Okay, sorry about that.
No problem.
So welcome to my talk. This paper is titled An Empirical Study on Release Note Patterns of Popular Apps in the Google Play Store. So this work has been done while I was an undergrad at Queen's University, but now I am a PhD student at Carnegie Mellon University. This paper was published in MC in 2021. So my collaborators are Safwat Hassan, Ying Zhu, and Ahmed E. Hassan at Thompson University and Queen's University. So to begin, I just wanted to give an introduction to what are release notes. So release notes are the notes that come with every release for an app on the Google Play Store or the iOS App Store. And so an example of a release note here is for Duolingo, which is a popular Pittsburgh language-based app. And so for this one particular release note, they talk about a new language tips icon. So for this feature, they talk about how to use the feature, what it's useful for, and if it's available in which types of different languages. So in this one, we see that their release notes are pretty specific. But there are tons of different other release notes. Some might just say bug fixes or minor improvements, or some might have very, very long and detailed what's new sections. And so we were wondering if developers really care about using release notes to make their apps better, and communicate to their user base, or if it's something that they just sort of write off as part of their release and don't care too much about. And so to do that, we start to do a qualitative research, which we use as a survey. So we survey 102 developers from that app development discussion sites. And we found that 67% of our surveyed developers frequently update their release notes. 78% of them say that they would definitely like a tool that helps them generate release notes so they don't have to write it themselves. 83% of the developers say that they can use release notes to respond to users instead of responding to users one by one with a message. And finally, 90%, so the vast majority of our survey developers say that release notes are very important for notifying the user base about recent updates to their app. So to make sure that our surveyed results are also shown in the most popular apps from a time frame, we perform a longitudinal study over 2,232 apps, which are some of the most popular and used apps on the Google Play Store in the last 3 years, which was 2016, which we collected from 2016 to 2019. Of those, we found 70,000 releases, 67 million user reviews, and 2.9 million developer responses to users. So with that data, we try to ask 3 research questions. The first one is, what are the release note update patterns? The second one is, what are the characteristics of apps that follow certain release note patterns? And RQ3 is, do developers ever change their release note pattern? And so to briefly mention the method we use, we measured the release note length and content updatability based on its cosine similarity to all of its previous release notes to find patterns. From those patterns, we try to build a regression model for each of the patterns that we find to see if we can find any correlation between patterns and app characteristics. And for RQ3, updatability to see if our apps change any of their release note patterns. And since I don't have time to talk about the results in detail, I'll just give a very quick summary. So for RQ1, we found 6 patterns of release notes. For example, some of the patterns have very short length and very short updatability. And so they always just say bug fix, instead of anything detailed. Or we can find, we see some apps that exhibit patterns like pattern 6 that have long length, so they have very detailed release notes, but they only update at major releases. So when it's a minor release, they don't actually say anything different. And from RQ2, we find that apps with longer and more updating release notes usually have higher perceived quality releases, an increase in user ratings, and more informative release notes for the user. Finally, for the shift pattern one in RQ3, we observed that 54 apps actually shift their release note patterns, and 92% of them actually go from uninformative and non-detailed release notes to informative release notes. So that wraps up my short talk. If you have the time to please scan this to get to the site of the paper, and thank you for listening. So should I stop share or keep it?
So, the second is another, if you reduce feedback time,
All right. Can you see my screen? All right, I think you can see my screen. I'm Peter Rigby. I'm stepping in for my student Mohammed, who is in Iran, and apparently mid-space and Iran do not get along. So I'm going to talk about batch testing And first of all, it's used very extensively in all large companies. Basically, when you're running your integration tests, you can't afford to necessarily test all individually, especially if you have thousands of commits every day. And so you have to group them together in some kind of batch. So the goal is to understand like how much can that save us, and then also when there's a failure, what different algorithms can we use to find that culprit. So just as motivation, if you had eight builds, you're grouping builds into, you have 8 commits builds that you're going to group together. If you group them into a batch of 8, then you just need 1 build test execution if they all pass, right? So you've saved 7 build test executions, which is huge, right? Unfortunately, when there's a failure, you have to do some kind of bisection. Git bisect only works if you have ordered commits. If they're not yet integrated into trunk, there's no order, so you have to go down both sides of the tree. And ultimately, you'll find the culprit, but it'll take you 7 build test executions, which is still less than all 8, right? Than running test all on every single one, which would have cost you 8 build test executions. Unfortunately, it can actually, if you have multiple builds that are actually failing and potentially different tests, you can actually end up with 9 build test executions or more, which is actually worse than just doing a simple test all, right? This idea of batching actually goes back to World War II, where they were doing syphilis testing, and they would group soldiers' tests into batches. And then if that batch was positive, then they test each soldier individually. So this is called dwarfment. And that's this line right here, which is sort of constant, right? You run one batch, and then on failure, you test everyone again to see who actually has syphilis. Interestingly, like just normal bisection is actually worse than dwarfment until you get to a batch size of 4. And then after that, if you only have 1 culprit, it's better. If you have multiple culprits, it can actually be worse, right? So we have a lot of, we did sort of like, worst case, best case scenarios in the journal paper. What we decided to do was to use bisection up until we got to batches of size 4. And then when you have a failure, you actually just test each one individually, because we've showed basically that it's always the same or better than doing bisection. When you actually run this on the largest Travis torrent projects, here we show, I forget the exact number, around 10 different of the largest projects, you can see the savings is actually enormous, right? So you save somewhere between 20 and 60%. It depends on the failure rate, which I'll get to next. But the interesting thing, and this is batch 4, if you just put things into batches of 4, most of the savings is actually with smaller batch sizes. As you get up to like batch 20, right, you have to put 20 commits into one batch, and the probability of any one of them failing goes up dramatically, right? So most of the benefit is actually seen in really small batches. Even batch 2 is highly effective, right? Where you can see it up at 40 or 50%. So we looked at different projects, like how their actual failure rate. So obviously, they have the low failure rates, like really effective. 60% of the build test executions are saved. But even up to 40%, so almost like some projects even 50%, you're actually seeing savings, right? And so it's highly effective even when there is quite a few failures. Now, the approaches that I've shown so far are very simple, but there's lots of like great work in the MSR community in terms of like doing risk prediction, like how risky is this change to introduce a bug, right? And the problem with a lot of that work is it's not that actionable. What are you going to do? More testing? You're going to do extra reviews? Here, we actually use it to say, well, what should be the size of the batch, right? And so this first build has like a really high risk of failure, right? Based on, we just made a simple bug prediction model. And it's a 45% chance it's going to actually fail. And so we're going to test that by itself. Whereas when the next 2, it's only a 20% chance. And so we can actually combine them together, right? And so in this way, we actually used, commit risk modeling to determine the size of the batches. Unfortunately, and this maybe is just because, there's a lot more sophisticated models than the one we use in the paper, it was actually less effective than just using batch stop 4. So doing bisection and then stopping once you got to 4 commits left. And so, I'd love to see, people who have more experience with risk batching, commit risk, making models and trying to see, can we actually group things into combinations that reduce the number of executions. I think that's pretty much all the time. But again, you can save like up to 60% of your executions by doing batching. And, you do need resource constraints. So you do need stuff actually waiting in the queue. But even if there's only 2 things in the queue, you might as well batch them together. You can save like 20, 30%. Thank you.
Thank you so much, Peter. 2015 work. And you progress in the third presentation is now from to Marcelo Fernandes, I think, will present. So DevOps education, an interview study of challenges and recommendations. Could you hear us? Hi, Marcelo. Hello, Marcelo.
Technical issues hearing us.
Hi, everybody. Unfortunately, I cannot hear the presentations. Okay, I changed my browser. I changed all setups of my microphone, but I could not. Okay, so I'm sorry. I'm okay. So I will do my presentation. So you can ask the questions, write the questions in the chat, and I will answer after. Okay. Let's go. Hello, everyone. My name is Marcelo Fernandes. I will be with you throughout this presentation. I'm going to present you our research about an interview study of challenges and recommendations in DevOps education. The software industry has embraced DevOps practice because it can effectively improve product and service delivery capabilities. So knowledge about this DevOps practice is essential for software developers nowadays. Unfortunately, DevOps is not usually part of the curriculum in many educational institutions, making it difficult to have a course as a reference. It would be helpful to know the main problems and the best educational practice to teach DevOps. Our work has 2 research questions related to challenges and recommendations in DevOps education. In our work, the pool of interviewees came from existing DevOps courses. We found courses searching on GitHub, Google, Alura, and our contacts. We considered the search strings DevOps course, continuous delivery course, and infrastructure as code course in GitHub and Google. We fortunately met great people, and we have learned a lot from them. We interviewed 14 educators from 11 universities in 5 countries. We have collected 83 challenges and 185 recommendations. Let's see some examples. Students have a prior concept that DevOps is restricted to the use of tools, not being interested in the cultural part of DevOps. The second one, people are very proficient in development and have no idea about configuration. And third example is about a lot of technology on the market. Now, some recommendations. They say the only way to experience the culture is to immerse the students in the culture. Second example, grade students based on their learning journey and mistakes, not on what they submit. And the third example, show case study about elimination of silos among the development and operations team. When looking at the most mentioned challenges, we can find sufficient time is the critical problem for the courses. There are several tools to learn, keep updated, but they are not the only focus of the course. Important balancing between theory and practice, background of students, sometimes insufficient and sometimes they are different. Importance to teach DevOps culture instead of only focus on tools. In terms of recommendations, we see the importance to have teaching method and assessment based on practical hands-on activity, the need to use more than CI and CD tools, and the need to teach CI and CD automation and the DevOps mindset. We grouped the challenges and recommendations into themes using the thematic analysis research method. The following themes were found: DevOps concepts, curriculum, assessment, tool and technology, environment setup, strategy and cost execution, and class preparation. If you want to see challenges in environment setup theme, you can filter specific ones. We linked the DevOps recommendations to challenge when the recommendations can mitigate or solve the challenge. For example, you can mitigate the challenge difficult in teaching students how to add new features without breaking the system with the recommendation, incremental teaching method based on project and practical activities. Another link example, you can mitigate the challenge difficult in structuring the learning journey with the recommendation, merge good practice of problem-based learning, inverted class, and agile through classroom experimentation. You can find this diagram in the paper that shows the most cited challenges with links for their recommendations. You can also find all the data set we have collected. The download link is inside the paper. We also identified scenarios that represent conflicts between challenges and recommendations. One recommendation says, force students to use technology stack used on course. Another one suggests, do not force the technology stack used by students in their systems. In this situation, we cannot decide if a strict technology stack is appropriate or not to use. Finally, if you are an educator, you can use the themes to navigate the set of DevOps challenges and recommendations. You can mitigate a common set of problems found when teaching DevOps using challenges and recommendations and their links. You can use the most cited challenges and recommendations as a good start to consider when preparing a course. And you should prepare your educational methodology to motivate students to understand the DevOps mindset and not only learn technological aspects. And if you are a researcher, you can use the themes to navigate the set of DevOps challenges and recommendations. You can investigate challenges with few links to recommendations, and conflicts also represent research opportunity. You should investigate on the aspects of DevOps educations that our interviews disagreed with. Thank you. Okay.
Okay, thank you so much. Marcelo cannot do this, but you go to the next presentation. So, lessons from 8 years of operational data from a continuous integration service. The floor is yours, Kehelia.
Hello everyone, I'm Kehelia Gallaba. My talk is about an exploratory case study of Circle CI that we conducted using 8 years of operational data. These days, many software teams are choosing to use cloud-based CI services because they take away the hassle of maintaining your own CI infrastructure in-house. For example, Travis CI, GitHub Actions, and Circle CI are few such services. There have been many prior studies on CI, for example, on benefits and challenges of using CI, also about CI build outcomes, such as build failures and noise, and then duration of CI builds, for example, long build durations. Then there was research about patterns and anti-patterns of CI usage. All of these focus on developer perspective for the benefit of developers, but provider perspective is largely unstudied. Therefore, we focus on provider perspective and how providers can benefit. So we look at 3 perspectives: usage of CI service over time, builds that can provide a signal to the user, such as tests passed or test failed, builds that are unable to provide a signal because they were abruptly terminated. So we decided to study Circle CI because it's used by over 1 million developers, used by many software teams, as shown by the number of installs in the GitHub marketplace, because it provides a robust API for us to access historical data of 8 years. So as the first research question, we look at usage of CI service over time. We study growth of 2 indicators. First, build duration, that is the time taken by a build to run from start to finish. Throughput, number of builds completed in a fixed time period. By plotting median values of these 2 indicators, it showed that the values have remained stable over time. That means Circle CI was able to provide a consistent service to the average user over time. However, when we plot the 95th percentile, it showed more and more heavy users are using the service. So this raised the question, how is these heavy users consuming the resources of the service? So by computing the Gini coefficient of 2 indicators, throughput and total build time, we observed that imbalance of resource consumption was growing over time. That means heavy users were collectively using more and more resources. So to summarize the first RQ, we found out the Circle CI service provider was able to provide a consistent service for the regular consumers. Consumption by heavy users was growing further. And then by studying signal generating builds, we found out for the average user, compiling and tests take up most of the build runtime. However, heavy user builds spend more time downloading dependencies. Then we looked at why some builds are unable to generate a signal. There we found out 4 main reasons. One is user cancellation, availability issues, configuration errors, and exceeding time limits. To address the limitations that we identified, we have some recommendations. So to reduce the load on the server by the heavy users, services can implement tools proposed in prior research for build acceleration. For example, some have proposed to use machine learning to skip CI builds. Some have proposed to selectively build based on some heuristics. Then the service have the choice of allocating future investments to benefit the average user. To make a lot of developers happy, they can choose to optimize compilation and testing stages by using techniques such as test selection proposed in research. Or they can make heavy users happy by allocating more bandwidth for downloading dependencies. For example, we have some more recommendations. You can read our paper for more details. That concludes my presentation. Thank you very much.
Thank you so much, Vidya. And just to remember that congratulations, your work was nominated as a distinguished paper. So super.
Thank you very much.
Congratulations. It's
Thank you.
really amazing work.
Thank you.
Thank you for the great talk too. So last but not least, now it's time to listen towards language-independent brown build detection. It's oh, great!
Thank you. Thanks for the introduction and welcome back. So I'm Bram Adams, and I'm presenting the work of my PhD student Dorian Olewiki, and the work is in collaboration with Mathieu Nerol from Ubisoft La Forge, and it's about language-independent brown build detection. So, given the previous talk, everybody's probably convinced that CI is the way to go for quality assurance. Just to summarize, you have a commit, you have a whole bunch of automation that is triggered when it happens, and automatically there's compilation and test. And some tests, some compilations might fail. And the big assumption being, okay, if the CI fails, either compilation or test, there's a problem, you have to do something. That's simple. However, there are like quite some cases where this assumption breaks. So if we have the same setup as we had before, some kind of failing tests or compilations, if you just retry and rerun them often enough, at some point they might suddenly succeed. They are called brown builds. And they succeed without changing anything. You don't change the code, you don't change the build setup, you just rerun often enough. Why would this happen? So, well, flaky test, you might be familiar with that, but also the build environment might suddenly break the connection with the game console because the video game company might be kind of intermittent and so on. And the problem is those brown builds are very common. So in these 7 systems that we studied, 6 of them are closed source, 1 of them is open source, use a variety and a combination of programming languages. We find that in terms of the percentage of failures that turn out to be brown, meaning they turn out to be a success after retrying, is quite high, like a median of 13%. 3 projects have at least 30% of those failures actually being brown, up to 58 for 1 project. So we have to do something, because if we just keep on rerunning stuff, things don't scale. We saw that in the previous presentation, and developers lose their trust actually in the CI. So what we do is actually we proposed a language-independent approach to predict brown builds. Based on the build job logs, we kind of do all kind of things to get n-grams from that. We do TF-IDF, we reduce the feature space using feature selection. We have some metrics about the build jobs, about the commits, and we have like XGBoost based model, actually 2 levels of that. All the data is on the paper. And then with that approach, we actually evaluated empirically. We empirically studied how well it performs first. And we found like a mean F1 score of 53% with peaks up to 84. So what we see here is the F1 score. Orange is our approach on the 7 projects. Blue is the baseline, random baseline. And we have like 2-3 times higher F1 than the random baseline. The highest score is actually for the project with the highest proportion of brown builds. Whereas the second highest project with second highest brown build ratio actually is the second worst. So there's some correlation between having brown builds and performance, but it's not 100%. We also compared to humans, how humans look at this. We looked at 6 build experts who looked at 40 build jobs. And there, orange is again our approach, green are the experts. We see that performance is quite comparable. Sometimes we're better, sometimes the experts. And of course, experts have to spend up to 3 minutes average per build log. So we save a lot of time just using a model. We also looked at when you apply the system actually in practice, how often you need to retrain the model to actually stay competitive. And what we found is that we came up with a bunch of heuristics, and our best heuristics have like similar performance as retraining every week, but with 2 to 6 times lower retraining cost. So let's look at that. So what we see here is again F1 score, orange, or our heuristics. We just show the best performing heuristic for these 4 projects. Blue is a random baseline. And we see that, okay, we are 2 to 4 times better than that baseline. Now, of course, we can try to find what's the optimal heuristic that would have picked the best kind of possible moment to retrain a model. That's yellow. And there we see that we're like 7 to 10% lower. Typically. And finally, if you compare to like systematically every week retraining, which is gray, there we see that we kind of in 3 cases at least as good or better, and in 1 case slightly worse. And the special thing here is that these models, the orange models, they survive like an average from 6 weeks to 2 weeks, whereas the weekly models have to be rebuilt every week. So that's why we have 2 to 6 times lower retraining cost for similar performance with our heuristics. All right, so we propose this approach for language-independent brown build detection. Check the performance as good as experts. We also did cross-project prediction. It works sometimes depending on the project. And also we found that we can get similar performance as weekly retraining, but with like a lot lower retraining cost. Thank you.
On time. Thank you so much, Ben, and thank you for all presenters. That's absolutely amazing to respect the time, despite of this small problem with our colleague was a chair. And so we are here just to open for questions and comments and discussions, because DevOps and this discussion is super, super cool. So maybe I have a question for you, Bram, because what you during your experimentations and data analysis and observations, did you see a difference between a game industry or game projects, characteristics or behaviors, and the traditional software engineering projects? Could you see different challenges on builds, or that you could comment a little bit?
Yeah, definitely. That's a great question. So for sure, these are huge, big systems. So that's one thing. Of course, there's other big systems, other domains as well. However, what really stands out is the fact that in a video game, you don't just have source code that you're compiling and testing. You have all these other kind of things around it, like artists, they create these objects, AI models, you have models for collision, like all these other kind of resources come with it. They have their tools that need to process them. They might fail during CI or during build. So that's why like build is not just code, and it's a lot more other kind of things around it. Hence, you need approaches like a language independent or resource independent, so to speak, that can deal with that basically. So that I would say that's the biggest thing that stands out.
Sure. Because
I have a question for you too.
Sure.
So Brown builds, obviously flaky tests are a big percentage of them. I think the environment also, I guess the test itself isn't flaky. You're trying to ignore these Brown builds. Is that your goal, or did the developers actually then go and like look at them and fix them? Like, what is the sort of outcome from your work? Like, what does the model do? Does it ignore Brown builds, or does it flag them differently, or like what?
So right now, so before this approach, there was already policy if a developer has any suspicion that a failure is not really a failure, to rerun it until they're sure. Of course, this increased the load on the CI server. So that's why one application of these models is already giving a second opinion to a developer before they start rerunning things. However, because that's the other problem is like it's not just the cost of like rerunning the build, because when you make the decision to rerun the build, it means you stop that commit from continuing the CI pipeline and other projects or games that might depend on something. So that's the other thing you actually save. So one thing is second opinion, avoiding these kind of things. But in the future, we try to see, can we go further? Can we somehow, based on prediction, do more than just that? Maybe find a fix or something like that's like definitely another application.
Yeah, it's interesting because we looked at flaky tests at Ericsson, and the goal was to actually ignore the flaky failures, right? And to actually say this test is behaving in a different way than it normally does. It's normally flaky, but it's behaving in a different way. So let's flag it now, right? And I feel like a lot of the research community on flaky tests are trying to find more flaky tests. But when you look at like at Meta, you look at Ericsson, there's a recent paper at Apple, they're actually trying to ignore these flaky tests. and I think like rerunning obviously is expensive, but that tends to be the general strategy, and then to look for like variations and stuff like that. But yeah, making a model. What were the predictors in your model? I'm curious.
Well, yeah, so the predictor basically, so the build log, so basically the terms like with stemming, all these kind of things, but also information about for a given build job, how long, how many builds or even commits since the last kind of rerun, information about the commit as well. So yeah, that's kind of the information we used. But just to piggyback a bit on the thing you mentioned about flaky tests, so for sure flaky tests they play a role here as well, but there were a lot of cases where the build environment, especially dependencies, like and were not available, or the wrong version was available, and that caused actually issues. So those kind of things that are really temporary and is really different from like regular flaky tests, for example.
Yeah, cool. Great, thanks.
Thanks for the question.
Also, if you prefer, you can.
Well, I can't hear you. I'm not sure if anyone else is having this issue.
All right.
Fabi, I can't hear you. I can't hear you at all. I don't think it's muted. It changes. The volume changes. Maybe it's your hand, or I'm not sure.
Now it's better? No? Just a second.
So actually, I got a question for the fourth speaker. Which was about the Circle CI and all the kind of build thing. And I was wondering, so you mentioned, actually, it kind of relates to also to Peter's paper, because at some point you mentioned that like batch testing could be a way to somehow like reduce load. But I was wondering, like, can you talk a bit more about that, especially with regards to what Peter was discussing in his paper?
Yeah, sure. So so what we looked at was the provider's perspective. So how the provider can optimize things to reduce the cost or provide a better user experience. So so batching may not work in that case. Like you cannot batch builds across multiple projects. Um, uh, Also, like developers may not like that idea. So what some suggestions we have is using build skipping. For example, there's prior studies about using some heuristics, using some past build history to skip builds, or using machine learning techniques to decide if based on the commit, if this commit can be safely skipped, techniques like that. Apart from that, there are other guidelines we provide for
I disagree with you about the batching thing. So if you have a single project that's using a vast amount of your resources, you could actually batch it and they would never even know. So like my student wrote like a GitHub plugin where it just waits, it just sees what's been committed and it just combine them if there's a need for it, right? And so you could actually make it, and it reports the result for each individual commit. It just, if there's a failure, it'll take more executions. But overall, it's saving like 20 to 60% of the executions. Another awesome thing about batching is that you don't skip anything. I've never seen a developer willing to skip just testing an entire build. I mean, maybe in an early stage of integration, but if you're going to be pushing that out, like in a CI/CD, you're just not going to test an entire build like that. That seems crazy to me. Like, I mean, the risk models were just, I mean, admittedly ours were fairly simple, but I don't know. I just can't see that. I just can't see that happening, like releasing something and not testing it. Like, I don't know. Developers have enough trouble skipping a single test, like test selection, let alone not running tests at all, right? And I think another really cool thing about batching too, over selection and prioritization, is that you run all of the tests, right? You don't actually skip any of them. It's just you group the builds together. And so any common test is only run one time for all of those builds, right? So I'm not sure why, as a research community, we haven't looked more at batching, because it's widely used in industry. I mean, in a sense, like any kind of where you merge a bunch of stuff into master and test periodically is a type of batching, and then you have to do culprit finding, right? So I personally would like to see, other people do. Like, there's so many different algorithms you could do for culprit finding too, right? And all of the risk models we've developed, which other people have done way cooler ones than I've ever looked at, I think could help with this too, right? So
yeah, I agree with you there. Like in terms of batching, you can use it in like a project level. The commits can be batched, but if you're thinking of like the service provider,
wasn't the problem that there was like heavy use projects, right? And they were taking up a lot of the resources. Like that's a great, I think, and you can do it. So like you can do it so that no one even knows you're batching. You can do it like that's one of the great things. Like when we did it at Ericsson, none of the developers knew that stuff was actually being batched. They get the result for their individual build. It just happens to be run in a batch, right? So that's one. I think it doesn't change the UI at all, which is, in my opinion, really cool. Sorry, I cut you off again, and I'm going to stop tooting my own horn. Sorry.
So now you can hear me? No?
So, but yes.
slightly better.
Because Carlos...
Yes, I want to talk because it's one thing that I don't understand in CI/CD after studying this topic, because when I manually testing and doing tests for the industry, this was the strategy. We have strategies. If we have we wait a little bit to have a test bench with many commits that we want to test, and because the human being isn't a cheap resource, then we need to use it wisely. And then because of this, we cache in the data, the batch, the versions, we have all this. But when we are looking for CI/CD and automated test, it's like we have unlimited resources. Okay, we are talking about 10 years ago with the initiation of the strategy, but now we are limited. This was a great idea and spreadly used with very common algorithms with success. It's a great job. I want to ask a question for Aidan Young. Can I do it now, or you?
Absolutely, go ahead.
Everyone want to discuss this topic more?
Absolutely.
Aidan, what do you want to research next? What do you want to see or seek? Looking at your paper, I am remembering CMMI, rational unified process that had this guidelines for release notes. They are huge. The Jira practice and checklist that when you use in looking for this release notes on Google Play stores, almost no one doing like the old stuff. Or where are you trying to reach now? You want to look forward, you want to compare the data that you have with what we have in the literature or in industry years after, in the 90s, in initial 2000s. What do you want to do next?
So for release notes in particular, the more we looked into it, sort of doing manual studies and reading a lot of these release notes, we found that some of the most successful apps actually have the release notes that don't fit a particular formula, but sometimes show a lot of personality. So for example, one app that was for, I think, some mini game for people to play, every holiday season they would say like super fun holiday season release, and so they don't actually follow any strict guidelines like, as you mentioned, like Jira's or commit messages, but somehow in those very fun and quirky release notes, we actually saw an increase in user ratings around that time. And so it is a good suggestion to look into guiding that more. And we did see from the surveys that people said it would be nice to have a set guideline to help us write or generate release notes. But from the results that we saw, it seemed like having more of a playful or freer way to write these ended up being correlated with better quality apps. So for this particular research, I think it's best to just let people write their release notes more informatively, as in they update more and they write longer ones instead of just following what is right, because we didn't find particular reasons for what some things were better than others.
Great answer.
Sure. Thank you, Carlos and Aidan. You have a question from Pei Liu to Kehlia. Are you going to release your data set and tool to public?
Yes, of course. So you can find a link in the paper. We have already released the data set and the tool. So you can find that in the paper. Yes.
So great. It's super, super cool that you share, and nice to know. Thank you for sharing. So the audience maybe, or some presenters.
So I'm yeah. Can you hear me?
Absolutely. Go ahead.
Okay. I'm Xin Peng from Fudan University. I'm very sorry that finally
No
I
problem.
have my access. Yeah, thank you. And thank you, Fabio, for helping me host the session. And I
My
have
pleasure.
a question for, yeah, thank you. I have a question for Cahilia. So you talked about CS. I think it's a cloud-based service. So can you comment on the technical problems from the perspective of operation? Because CI service is cloud-based. It means that it will consume a lot of different kinds of cloud resources, and quality of service is highly relies on highly influenced factors such as the hardware, and also maybe the system software, and also the force in the source. Yeah, I mean, can you comment on technical problems from the perspective of operation?
Yes. Thank you very much for that question. So from what we found out, based on what developers are doing at different stages of the CI process, there are different requirements, right? For downloading dependencies, you will have to have a high network bandwidth. And if it is like IO based, a lot of disk writes are there in certain steps, those needs to be optimized. And if it is CPU based, if there are a lot of compilation going on, so based on certain steps, and for certain projects there may be different requirements. So based on that, the service provider should be able to cater to those requirements. That's one observation. And the other thing is, so we are looking at this from the data available for us as a external entity. So we are using the version build history to gather information about their operations. So we don't actually have access to the Circle CI service to tell more details about how they are operating. So, so in this paper, it is limited to what we can observe from their APIs. But we have shared this paper with them, and we have we are in discussion with them to get more ideas and more feedback from them.
Okay, thank you. Yes, I think my question is more about the operation data of this kind of CI service. That means that we need to get some operation data from the internal servers of those providers. I know Huawei also has some public cloud service, and also their PaaS service, I think, includes this kind of CI service. So maybe in the future, maybe if you can have the opportunity, maybe you can use this kind of operation data to learn more about this issue. Yeah, thank you.
Yeah, thank you very much for that suggestion. And also another comment about that, for these operational data in Circle CI service itself. So from the API, by looking at the API, we observed certain outages, infrastructure failures. We were able to verify those were actually happening by going into forums and looking at their outage messages to actually like link the failures we observed from the API that were their internal failures. They were like putting out messages about that, and giving messages to the user base about that. So yes, we can have more information if we can internally dig into these operational data. Yes, I agree. Thank you. Thank you for that suggestion.
Okay, thank you. Thanks.
We have a question to Marcelo. Marcelo, I think that you can. Okay.
Hi.
Hi, Marcelo.
Hi, Fabio.
Okay, you have a question from Bran. In what year should... Well, you can do that, Bran. Go ahead.
Yeah, so,
Okay.
so I'm wondering, so like, would it be undergrad or grad course? If it's an undergrad course, would it be an early one, a late one? Like, what's your view on that?
Well, in our interviews, we found many DevOps courses happening in the end of an undergraduate course and in different stages in professional, master, and PhD course. Some people want a specific classes about DevOps, but I've heard too that we should not have any specific classes about DevOps. We have to take the best DevOps practice and do this practice during all of disciplines. Okay, well, during programming classes, you can use some DevOps practice. During databases classes, you can use some DevOps classes. When you teach security classes, you can do some DevOps security practice too. So we can use some different techniques to teach DevOps. You can use specific classes, or you can use already classes to introduce some DevOps practice. So that's what we found during our interviews. Okay.
Great, thank you.
Thank you for your question.
Just for complementing Marcelo, there is this difficulty that in undergraduate course we have found just in final. It's because we have the teacher, the professor needs to teach database, networking, and if they chose to use in a final part of the course, it's more easy to have this prerequisite in the course. So.
Okay, I have just a quick question to say, what is the experience of the instructors that you interviewed?
All of the interviews are very experienced people. They are usually more than 5 years teaching. Okay, and they say that it's hard to know so many things to teach DevOps. We have to learn dev, and we have to learn operations also. So it's not easy to stay up to date with the technologies too. So the professors usually have some TA, they have teacher assistants to do the classes also. We found this information during the interviews.
Great. Okay. So it's a great session. The time runs fast when you have a really nice topic to discuss. Great work, great talk, great people. Congratulations for all presenters. And I hope that you enjoyed as me this session. So thank you so much. And see you around in Nixie. Bye-bye.
Thank you. Bye-bye.
Thank you. See you.